Ever wondered what makes our sun so special in the grand cosmos? Well, let's uncover the secrets of this glowing celestial body. Sitting at the heart of our solar system is the sun, a shining star that gives life to our existence. But did you know that our sun is classified as a G-type main sequence star? In simpler terms, it's often referred to as a yellow dwarf. This isn't because it's small or insignificant. In fact, it's anything but. The name simply refers to its color and spectral type. And if you're curious about its age, our sun is roughly 4.6 billion years old. That's right, it's been around for billions of years, fueling life and illuminating our skies. So our sun is not just any star, it's a yellow dwarf that has been burning bright for over 4 billion years. The sun, it's a giant compared to us, but how giant exactly? Let's start with its size. Picture Earth, then imagine it expanding until it's 109 times larger. That's the diameter of the sun. It's like stacking 109 Earths side by side. Quite a stretch, isn't it? And that's just the diameter. When we consider the volume, the sun could hold over 1 million Earths. That's a lot of space. But size isn't everything. The sun's mass, or the amount of matter it contains, is about 330,000 times that of Earth. That's equivalent to 330,000 Earths all squashed together. This massive weight gives the sun an immense gravitational pull, strong enough to keep all the planets, asteroids, and comets in our solar system in check. Speaking of the solar system, did you know that the sun holds 99.86% of its total mass? That's right. Nearly the entire mass of our solar system is concentrated in the sun. Everything else, the planets, moons, asteroids, comets, and dust, they only make up a minuscule 0.14%. It's incredible, isn't it? But the sun isn't just an enormous mass floating in space. It's a dynamic, active star. It's constantly changing and influencing everything in its vicinity, including our little Earth. It's the engine that drives the solar system, the heart that keeps it alive, and the beacon that lights our way. So, the sun is more than just a bright spot in the sky. It's a colossal, powerful star with a size and mass that are hard to comprehend. Yet, despite its vastness, it's just an average star in a universe filled with billions of others. That's a humbling thought, isn't it? In the grand scale of the solar system, our Earth is but a small speck compared to the colossal sun. It's hot in here, but how hot is the sun's core and surface? Imagine a place so hot that it makes our planet's hottest desert feel like a winter day. Welcome to the sun's core, the very heart of our solar system's star. The temperatures here are beyond comprehension, reaching a blistering 15 million degrees Celsius. That's over 27 million degrees Fahrenheit if you're following along in imperial units. The heat is so intense that it fuels a process known as nuclear fusion, a reaction that converts hydrogen, the simplest and most abundant element in the universe, into helium. This isn't just any ordinary transformation. The process of nuclear fusion releases a tremendous amount of energy. It's like having billions of hydrogen bombs exploding every second. This energy radiates outward from the core, passing through the sun's various layers until it reaches the surface and then continues on its way to the farthest reaches of the solar system. But what's happening on the sun's surface? If you think it's as hot as the core, you'd be in for a surprise. The surface, or photosphere, of the sun is significantly cooler, with temperatures around 5,500 degrees Celsius. That's just under 10,000 degrees Fahrenheit. Yet even at these cooler temperatures, the sun's surface is still hot enough to give us the light and warmth that sustains life on Earth. The surface is also where we can observe sunspots, darker and cooler areas caused by intense magnetic activity. These sunspots, along with solar flares and other solar phenomena, are indicative of the dynamic and energetic nature of our sun. From its core to its surface, the sun is a powerhouse of heat and energy. It's a constant nuclear furnace, a beacon in the darkness of space, and the central body around which our world revolves. As we continue to study and understand it, we gain more insight into not just our solar system, but also the wider universe and our place within it. The sun isn't always calm. Ever heard about its temper tantrums? The sun, like a rebellious teenager, has its moments of intense activity. One of these is the phenomenon known as sunspots. These are cooler, dark regions on the sun's surface caused by magnetic activity. They're akin to zits on a teenager's face, but with a lot more power and influence. Now imagine a zit popping, but on a solar scale. That's what a solar flare is. Solar flares are powerful eruptions of energy and particles from the sun's surface. They're the sun's way of releasing pent-up energy, kind of like how you might vent after a long, stressful day. But the sun doesn't stop at flares. It also experiences coronal mass ejections, or CMEs. These are massive eruptions of solar material and magnetic fields into space, like a supercharged volcanic eruption. You might be wondering, does all this solar activity happen randomly? Well, not exactly. The number of sunspots and the frequency of solar flares and CMEs vary in an approximately 11-year cycle known as the solar cycle. It's like the sun's personal calendar, marked not by days and months, but by magnetic activity. But here's the real kicker. The sun's activities don't just stay confined to the sun. They can impact Earth's magnetic field and cause what we call geomagnetic storms. These storms can mess with our satellite systems, disrupt power grids, and even produce stunning displays of the northern and southern lights. So, the next time you feel the warmth of the sun on your skin, remember that there's a lot more going on. The sun isn't just a glowing orb in the sky, it's a dynamic, active star with a life of its own, and its activities are not just spectacular to observe, but they also have significant impacts on our planet. Our sun has a strong pull, but how does it affect us, and how do we keep an eye on it? Well, let's dive in. The sun's gravity is a force to be reckoned with. It's like the conductor of our cosmic orchestra, keeping planets and other objects in the solar system dancing in their orbits. So, every time you gaze up at the night sky and marvel at the moon, remember, the sun's gravitational pull is the reason it's there, circling us faithfully, night after night. But the sun's gravity doesn't just hold the solar system together. It also plays a key role in causing tides on Earth. Think about it. The rise and fall of sea levels, the gentle ebb and flow of the ocean's rhythm, is all orchestrated by the sun. In collaboration with the moon, the sun's gravitational pull causes high and low tides, influencing marine life and shaping our coastlines. Beyond its gravity, the sun also sends out a stream of charged particles into space. This is known as the solar wind. Imagine it as a cosmic breeze, constantly blowing and carrying particles from the sun's atmosphere out into the farthest reaches of the solar system. This solar wind can interact with Earth's magnetic field, causing spectacular displays like the northern and southern lights. So, how do we observe all these effects? Enter the Solar and Heliospheric Observatory, or SOHO for short. This space-based observatory continuously observes the sun, providing invaluable data about its activity. From spotting sunspots to monitoring solar flares, SOHO helps scientists understand our star and predict its behavior. From its gravitational pull to the continuous stream of solar wind, the sun has a profound influence on our solar system, and thanks to technology, we're keeping a close eye on it. So next time you feel the sun's warmth on your skin or watch the tide roll in, take a moment to appreciate the sun's vast and varied influence. So, how far away is this magnificent star from us? Well, brace yourselves for this astronomical figure. The sun is a staggering 93 million miles away from our home, Earth. Yet despite this vast distance, it profoundly shapes our lives and the entire solar system. Let's take a quick stroll down memory lane, shall we? We've learned that the sun, a G-type main sequence star, or a yellow dwarf if you will, is at the heart of our solar system. Its colossal size and mass dwarf that of Earth, holding about 99.86% of the total mass of the solar system. Its core, a fiery furnace, triggers a chain reaction, converting hydrogen into helium and releasing a tremendous amount of energy. The sun's activities, like sunspots, solar flares, and coronal mass ejections, are marvels of nature that can even influence Earth's magnetic field. So there you have it, 20 enlightening facts about our very own star, the sun. It's not just a light in the sky, but a fascinating celestial body with a profound influence on our lives and the entire solar system.